Okay. What I want to know, again, hopefully this is the last time I'm going to ask this question. What is the whole point of stoichiometry? Yeah. Going from the chemical amount of one thing, right, the number of moles of one thing, to the number of moles of another thing. That's the whole point of stoichiometry. That's as complicated as it will ever get. If you can get moles of this thing, then you can turn it into moles of that thing using stoichiometry. And then from moles of that thing, you can figure out anything you want about it, right? You can figure out concentration, you can figure out mass, you can figure out pressure, you can figure out temperature, you can figure out volume, you can figure out whatever you want about that new substance. And so we've already done gravimetric, which was all about masses. Typically, what are you going to use in addition to the mass? The molar mass, typically, right? Go to mass moles, you need molar mass, okay, perfect, no problem. Typically, if you want something to do with gases, like pressure or temperature, what do you probably have to use in conjunction with your molar ratio in order to get pressure and temperature? It's either going to be that R value, or it's going to be the molar volumes at STP and SATP. Now, this is solution stoichiometry. In my mind, solution stoichiometry is just as easy as gravimetric stoichiometry. Solutions are defined in a couple different ways, okay? You can define the volume of a solution, and then you can define one other characteristic. What's the only other characteristic you can define about a solution? Yeah, the number of moles in that volume. So concentration, right? So stoichiometry process of going from one moles to another moles. In solution stoichiometry, we need to be able to find the chemical amount of a substance from concentrations and volumes. Usually, what are molar concentrations or amount concentrations measured in? What are the units for amount concentration? Moles per liter. And what are volumes typically measured in? Liters, right? So hopefully this is going to be fairly straightforward. That's going to lead us to be able to get moles. Okay, no problem. Example number 1. A 200 milliliter sample of a substance has a concentration of 0.378 moles per liter. Calculate the amount of a substance in the sample. So what I'm curious about is calculate the amount. What does amount mean? What unit is that? Moles, okay. So we're looking for the number of moles. Do you see anything to do with moles here? Yes, you do. I see 0.378 moles in 1 liter. And can we cancel out the liters in any way, shape, or form?
Yeah.
Yes. With what value? There's 2 things you could do. There's 2 different things you can do. You can leave it in milliliters, 200 milliliters. And what are your units going to be? What units are you going to end up with? Millimoles, which is just 1,000th of a mole. So you can get millimoles, and that's perfectly fine, right? So if we were to go that times 200, we would get 756, or 75.6. Yeah, so we get 75.6 millimoles, right? Or you could have changed the milliliters into liters, and that would have been totally fine too. If we changed the milliliters into liters, we would have said 0.378 times, what's this in liters though? 0.2. So you could have said 75.6 millimoles, or you could have said 7.56 times 10 to the negative 2 moles. That's the answer that you would have gotten, right? these two things are the exact same number. They mean the same thing. If I'm asking for you in millimoles, then that's a great answer. If I'm asking for it in moles, then that's a good answer. Whatever. We'll figure it out. Can I get you to try the second question? This is nothing new. You're just trying to figure out what volume from concentration and chemical amount. I'm trying to figure out what this is in my head, and it's like 4.4 something, or
0.0.
oh, sorry, yeah. But this it's going to be like 0.04.
Whatever you want.
Whatever I want. 0.05 what? Just that's 0.05 liters?
Yep.
Exactly?
Yeah, moles.
Right? Yeah, of potassium hydroxide, right? I mean, this would be an acceptable answer, but the more appropriate answer would be 5.00 times 10 to the negative 2 liters, yeah, of potassium hydroxide, sure. Why did I hesitate? Why did I hesitate when you said 0.05? Significant digits. We need. Do you know when you say 0.05, what that means is you know that this 5, or you're pretty sure that 5 is actually a 5, but then you're like, I don't know if that 0 is a 0, and I don't know if that 0 is a 0, and I don't know if this 0 is a 0, and I don't know if this 0 is a 0. You know what I mean? You have no certainty after that point by telling me 0.05 liters. But you do have certainty. When you take 3 digits and divide it by 3 digits, you should have 3 digits of certainty, right? So it's important for you to be able to communicate that in your answer. Okay, so that's great, that's awesome. That's a little bit of preamble towards getting worked up for our stoichiometry. So solution stoichiometry is the idea of using concentrations and volumes to calculate the mass or the concentration or the whatever of an additional substance. The first one, ammonia and phosphoric acid solutions are used to produce ammonium hydrogen phosphate fertilizer. Wow, Mr. Walton. Fertilizer. I don't know what the hell that is. That's okay. What volume of 14.8 moles per liter ammonia is needed to react with 1 kiloliter of 12.9 moles per liter phosphoric acid? Jeez Louise, holy guacamole. What I want to bring your attention to here is ammonia and phosphoric acid solutions are being used to produce ammonium hydrogen phosphate. So let's just write that out. What is ammonia? What does ammonia look like? NH3. And it says it's a solution, so we'll say aqueous. And then phosphoric acid. What in the good gracious hell is phosphoric acid? H3PO4. Aqueous. And what is it making? What's the only product it's saying? Ammonium hydrogen phosphate. That's maybe the toughest compound for people to figure out the formula to in the entire world, ammonium hydrogen phosphate. I want you to try and figure out what would the formula be for ammonium hydrogen phosphate. It's just a little mini test, a little mini quiz inside of a lesson. Try and figure out what the formula for ammonium hydrogen phosphate is.
And that's for
I don't know.
I think.
I don't know.
And that's for
NH3, 2 in brackets 2 and phosphate has 3. Wait. Does it have 2 negative ions? No, that's 2. I don't know.
Touching it now, I can. Maybe. Oh, I can't. I don't know. No, it's got
Say it as 3.
Yeah. Okay. The first thing I want to ask you is what kind of substance is ammonium hydrogen phosphate? Is it molecular? Is it an element? Is it ionic? Is it acidic? What is it?
ionic.
It's ionic. How do you know it's ionic? Because ammonium is the only other positive ion other than metals, right? We know anything that starts with a metal is ionic, but the only other thing that makes a positive ion, at least as far as we're concerned, is ammonium. So this is ammonium is a positive ion. Now, everything else in that name, it says ammonium hydrogen phosphate. There's ammonium, sure. All the other crap, it should be one ion. Where do you see hydrogen phosphate? It's in the table of polyatomic ions. And what kind of a charge does hydrogen phosphate have? It's got a 2- charge. So how many ammoniums and how many hydrogen phosphates do we need? Okay, well, ammonium is NH4 and we need 2 of them, right? And then hydrogen phosphate is HPO4. Boom, no problem. Easy peasy lemon squeezy. It's probably going to be aqueous. Okay. Is this a balanced chemical reaction? No. How do we balance it?
No.
No, it's not going to be annoying.
Put a 3 up front.
Yeah, 3 hydrogen. Let's separate hydrogen.
9 hydrogens on the right side. Wait.
Put a 2 there so
Is that 9?
Put a 2.
4?
Yeah.
That's it?
That's it.
That's it?
There's an 8.
What about the hydrogen?
I don't know, you add them up. Tell me how many hydrogens are on the left side.
9. There's 9 on the
I see 6 plus 3 is 9. And I see
4 years.
2 times 4 is 8, plus 1 is 9. Shucks, huh? It's okay, it's okay. Okay, basically what's happening is that each of these ammonias is stealing a hydrogen away from the phosphoric acid. So if these ammonias, if they each steal 1, right? So 2 hydrogens leave, how many hydrogens do we have left? 1, HPO4. And where did those 2 hydrogens go? Well, they both went on to ammonias, turned into ammoniums, right? That's all that happened, is that one ammonia stole a hydrogen, turned into ammonium. A second ammonia stole, turned into ammonium, right? So you have ammonium hydrogen phosphate. Now, I'm not going to be that big of a dickhead, okay? I'm not going to be that big of a D-bag on a quiz or a test or something like that. I just want you to understand that this is not particularly complicated. Yeah, don't show your parents, whatever. It's okay. And if you do and I get fired, then say la vie, whatever. That's the way it goes. So do you know anything about these substances? Do you know anything about these substances?
Plug in
Yes.
the numbers.
Yeah, you plug in the numbers, that's right. What volume of 14.8 mole per liter ammonia? So I'm going to put 14.8 moles per 1 liter. And this is of ammonia, right? Is this any different from anything that we've done so far? No! You know how to do stoichiometry. Okay, was got to react with 1 kiloliter, so 1.00 kiloliters of phosphoric acid. And what's the concentration of phosphoric acid? 12.9 moles in every 1 liter. Remember, as long as you can get moles of one substance, you can get moles of the other substance, right? So let's think about this. Of this substance here, can we get moles out of this? The combination of liters, moles, and liters. Yeah, hell yeah, we can, absolutely. I missed a crucial piece of evidence, though. I missed 2 things, technically.
The volume of
Yeah, we're looking for the volume of this. That's important for us to know that that's our unknown. And now we know that that's our unknown and this is our given. What's the molar ratio? 2 moles of ammonia for every 1 mole of phosphoric acid. How are you gonna begin this? Start with what you want. What do you want? You want the volume, right? You want the volume of that unknown thing. So where do you see anything related to volume under ammonia? The concentration. What do we have to do to the concentration? Flip it. So we're looking for volume in liters of ammonia. In every 1 liter of ammonia, there's 14.8 moles of ammonia. So I want to cancel out moles of ammonia. Where else can I cancel out moles of ammonia? Oh man, you're getting so sick of me, aren't you? You might as well be honest with me. We're in it for the long haul now. Some of you even have me next semester. Oh, that's going to be a grind. Goodness gracious. Moles of ammonia, moles of ammonia. Maddie, are you thinking about switching out to somebody else's Chem 30 class?
No.
Yeah, you are. I can see it in your eyes. Okay, let's try this. You got to cancel out moles of phosphoric acid.
Yeah.
We have moles of phosphoric acid here. Moles in 1 liter of phosphoric acid, H3PO4. And then the only other thing I got to cancel out is liters. 1.00 kiloliters of phosphoric acid. Ugh. So kiloliters, sorry. I want you to try and tell me what units get canceled out and what your answer is going to be. That's what I would like you to do. Ugh. Just exasperation, that's all I hear. Exasperation. Ugh. 26 divided by 15.
Is she right?
Does anybody need a calculator? That's one potential answer to this problem. You don't have to write kiloliters. Instead of writing the letter K, what number could I swap for K? Times 10 to the 3. How did you know that? How could you possibly figure that out? You can memorize it. You can know that kilo means 1,000, and it helps if you know French words, right? Doesn't it? Yeah. Because the French developed the metric system, and kilo stands for something 1,000. I don't know. I'm not French. Whatever. But it's something to do with 1,000. So that you could say 1.74 kiloliters, or you could say 1.74 times 10 to the 3 liters. Either one of those answers is completely, totally appropriate. Okay, was this radically different from the other stoichiometry we've been doing? No, it hasn't been radically different. In an experiment, 10 milliliters of sulfuric acid reacts with this many liters of potassium hydroxide. This is actually an unfair question for me to give you because there's two potential reactions that we could write. The reason why that is because sulfuric acid, remember, is polyprotic, right? So I'm just going to give you the reaction because I think this is unfair of me to ask you this. So H2SO4 reacts with potassium hydroxide, aqueous. And let's say it completely neutralizes the sulfuric acid. So we're going to get potassium sulfate. Right? The K kicks out the H. And what are we going to get in return? What's the only other thing we're going to get? HOH, otherwise known as water. So we're going to need two of these, and we're going to need two of those, and then that's our balanced chemical reaction. Do you want to try this, or do you want to try it together? Together?
She's not going to do anything.
Oh.
I see.
For Maddie's sake, we're going to do this one together. So in an experiment, 10 milliliters of sulfuric acid reacts with 15.9 milliliters of potassium hydroxide. And the concentration of potassium hydroxide is 0.150 moles per 1 liter. We want to know what the concentration of this is. So the molar ratio is 1 mole of H2SO4 for every 2 moles of KOH. Okay, we're looking for concentration. Akua, because you threw Maddie under the bus, what is concentration always measured in? It's measured in moles? Well, it's moles is part of it. There you go, moles per liter. Perfect. So we're looking for the amount concentration in moles per liter. Quickly look up at your information, do you have anything to do with moles of sulfuric acid? Sorry, yeah, do you have anything to do with moles of sulfuric acid?
Yeah.
What?
Do you have anything to do with moles of sulfuric acid anywhere in your information? Yeah, the molar ratio. 1 mole of H2SO4 for every 2 moles of KOH. Can you cancel out moles of potassium hydroxide with anything? Do you have, look under potassium hydroxide, are there moles?
Yes.
Yes, the concentration, right? Moles of potassium hydroxide for every 1 liter of potassium hydroxide. Remember, every time I write a unit, I'm going to write what that substance belongs to, or what that unit belongs to. Okay, now I need to cancel out liters of potassium hydroxide. Do you have anything to do with liters of potassium hydroxide? Yes. 15.9 milliliters of potassium hydroxide. So let's think about this for a second. Liters of KOH and liters of KOH disappear. Moles of KOH and moles of KOH disappear. Lovely. Are we done? What unit do we have right now? The way I've written it right now, what unit are we left with? Moles of sulfuric acid. And what do we want on the bottom? We want liters. So what I'm going to do is I'm going to divide by liters of sulfuric acid. How many liters of sulfuric acid do we have? 10 milliliters of sulfuric acid. How come I'm not changing the milliliters into liters?
Just cancel them.
What happens to the millis? Milli and milli cancel out. And what units are you left with? Moles per liter of sulfuric acid. Woo! That's what I'm talking about. So the concentration in moles per liter is going to be... Yeah, I'm not even going to try this in my head. 15 times 15 is 225.
925.
What?
0.11.
0.11? 1192? Sure.
Maybe.
Did you get 0.1192 something
It's just
moles per liter?
925.
925? Okay. Okay. I mean, that's wrong, but
Yeah.
yeah, okay. But we already knew that. 0.119 moles per liter of sulfuric acid, H2SO4. Blah, blah, blah. Any questions about that? Is that pretty straightforward? A little bit straightforward? It's a lot straightforward. Are you sick of stoichiometry?
Yes.
That is, for the time being, the last time we're really going to talk about stoichiometry. I mean, for 3 days. Then we'll come back and talk about stoichiometry again. Yeah. Woo! Man, gotta love you some stoichiometry. So, yeah. Yeah, I would like you to give I would like to give you an assignment if that's okay.
It's not. I prefer it.
Yeah. This assignment has gravimetric, it has gas, and it has solution stoichiometry on it.
You wanna do my sheet for me?
Yeah. I have all the faith in the world because you have 3 minutes left.
It's only 3 states though.
I have all the faith in the world that you should be able to get this done by tomorrow.
Plasma is not too common in chemistry, so we don't use it. What?
React violently? You don't get that? Can I show you? Can I show you the difference between a reaction and a violent reaction?
Go ahead.
Are you gonna put up a nuclear bomb?
What?
They're gonna be like
Do you say? Is there gonna be what?
they're gonna be like they're gonna be bitches.
Like, what are you trying to say?
Violence.
You can't solve yourself, you can't get the answer.
Oh. Really? I handed out 11 to that row, or I thought I handed out 11.
Having fun hearing you make no. Sulfur is solid.
So Akua, we've seen reactions that weren't particularly violent, right? That's you mix 2 things together and nothing really happens. It's not a violent reaction, right?
Is SL3.
I can see it. Wait, is that the what?
Ah, shut up. So all that is potassium chlorate or potassium perchlorate, whatever you want, and then we're gonna add a gummy bear to it. And does that when the gummy bear is sitting in the potassium chlorate, does it seem like it's maybe a violent reaction?
No.
It's very
They're really rude to each other.
Yeah. So that's what we would describe as a violent reaction. It's extremely exothermic, right? It's releasing a lot of energy. And that's how you would describe a violent reaction.
Wait, we should bring this instead of lighters in the campus.
No. Okay, let me know if you have any questions. I think most of these